This in the book for the Make Electronic by Charles Platt. I'm following the guide using the bistable mode for the 555 timer here. So what I did here is the breadboard circuit to make the 555 timer its function as a flip-flop here. So this is the bistable mode for 555 timer. Okay, this is the circuit which I already created. There is a way for 555 timer known as bistable mode, as this circuit is configured in this way, which is known as bistable mode. The two resistors from the left, which is 10k each, is act as a pull-up resistor for, you see you got two push button here, which act as a pull-up resistor for the 555 timer as well. And the one resistor, which is 470 ohm, is act as for the LED here, is to protect the LED here. 470 ohm for protect the LED, and two resistor which is 10k ohm, it act as a pull-up resistor here. What it does here is this timer circuit will act as just like a flip-flop, as it flip to on and in off state. So it's both as on and off state. You can see from the circuit there is no RC network for the configuration for the circuit, as there is no the resistor and the capacitor combination. Therefore there is no timing function here, because there is no resistor and capacitor presence in the circuit here. For this 555 timer, basically pin 1 was used, which is pin 1 was used, 2, 3, 4, 5 and 7 here. So there is around 6 pin was used for the 555 timer, consists of 8 pin from the 555 timer here. You can see the configuration here is called the bistable because it's stable when the output is high and it's stable when the output is low. Alright, negative pulse from the pin 2, you can see here, which is the pin 2 here, turns the output positive and latches it to the ground here, as well as the negative pulse to the pin 4 turns the output negative and latches it to the ground here as well. So what it does here is it sort of store the value, either is high or low, or in digital circuit it called as 1 or 0. Alright, how this is basically, let's say how the computer store the information. Basically just we put it from the positive rail. There I got a battery terminal here. I just apply the positive rail here. In this case this is negative, I just make it as positive because it's kinda easier for me to just put it here. But this is actually the positive rail here. I make it as positive here. Okay, put one positive here. Then ground we put it here. Then you can see it kinda light up a bit because there's some sort of pulse getting, but it is straight away turned off from there. So what you can see here is when I on this state, it will really light up. This is on state and this is reset button. This is on button and this is reset button. When I off, it will be off here. Let's say I on here and the LED is light up, and let's say I just take it off here, take it off the battery source here, then I put it back. So what you can see, the LED is still light up even though I don't have to press the push button here, because this is what we call how the computer you kind of visualize the concept how the computer store the information for the ROM and EEPROM. Let's say if it's a low state, I make it a reset, then I take off the battery compartment here, then I put it back. You can see here this is still low here because it's kind of like store information. This is what we call flip-flop because it store the value. Flip are on and off, flop is off state mode. Okay, that's you can visualize how the concept the computer store the information. This is the most basic fundamental for the digital circuit, where it store the value in 1 or 0. Alright guys, store 1 0 1 0. Okay, that's about it, guys. Thanks for watching. Don't forget to like and share and subscribe. See you in the next electronic project I'm making. Bye.